Welcome to qnawire.
So firstly, for a planet with its orbiting moon, we have that the force between them by the gravitational force law is equal to the gravitational constant g times the mass of the planet, big M, times the mass of the moon, little m, over the separation between them, squared, r squared. And this force is also equal to m times the normal component of the acceleration of the planet in its orbit. And this is equal to m v squared over r. So gmm over r squared is equal to m v squared over r. And so rearranging this equation, we can see that the speed of the orbit of the planet around, or the moon around the planet, squared, v squared, is equal to gm over r. But this is equal to g r squared over r, because we know that g times the mass of the planet is equal to the gravitational acceleration on the planet's surface times the square of the planet's radius, capital R squared. So if we take the square root of both sides, we get that v is equal to big R times the square root of g over little r. And we also know that the period of one orbit, tau, is equal to the distance covered in that orbit, the circular distance 2 pi r, over the speed of that orbit v. So this is equal to 2 pi r over big R into the square root of g over little r. So what we can do from here is rearrange this equation and find an expression for the radius of the orbit of the moon around the planet. And this is equal to g times the period tau squared times the radius of the planet, capital R squared, over 4 pi squared, all to the power 1 over 3. So there we have the expression for the radius of the orbit of the moon around the planet in terms of the radius of the planet, big R. So that's the first expression that we require. So from here, if we solve for g, the gravitational acceleration on the surface of the planet is equal to 4 pi squared times r cubed over tau squared r squared. So what we'll do here is we'll apply the data that we have for Jupiter and Europa. So Jupiter is the planet and Europa is one of its moons. So what is the gravitational acceleration on Jupiter? Well, Europa has a period of 3.551 days about Jupiter, and this is equivalent to 306,806 seconds. So therefore, the gravitational acceleration on the surface of Jupiter, we'll call it Gj, is equal to 4 pi squared times r cubed for Europa's orbit over the period of Europa's orbit squared times the radius of Jupiter. And so we can substitute all our values here that are known. So that's 4 pi squared into 670.9 times 10 to the 6 meters, all cubed, divided by the period, which we just calculated in seconds, to be 306,806 seconds, and that's squared, times the radius of Jupiter, which is 71.492 times 10 to the 6 meters. And that's also squared. So we get our answer in SI units. The gravitational acceleration on the surface of Jupiter is 24.8 meters per square second. So this is roughly 2.53 times the gravitational acceleration on Earth.